Since 1908 and the production of the Model T Ford, cars have been available to the general public. Now, over a century on, cars are a major part of our lives.
We're going to be looking at the emissions control in petrol engines used by vehicles and what is done to control them. Much has changed since the first cars, but legislation controlling the emissions weren't introduced until 1967 in California by an agency called CARB. Since then, emissions control regulations have become stricter.
Petrol engines, or spark ignition engines, work in simple terms by igniting a mixture of fuel and air to produce power. The burning of this fuel is a chemical reaction which has several inputs and outputs. The energy given out by the reaction supplies the power.
The fuel and air are injected into the engine. Currently, general petrol consists mainly of carbons with between 4 to 10 carbon atoms.
There is also other trace elements such as sulfur. The air in the atmosphere is roughly made up of 78% nitrogen, 21% oxygen, 0.4% carbon dioxide, but there's other traces of many other gases.
The output emissions vary depending on the fuel-air mix, but in general the emissions are nitrous oxides, sulfur oxides, water, carbon monoxide, carbon dioxide, unburned hydrocarbons and some particulates.
Okay. Carbon monoxide binds to the blood and reduces its ability to carry oxygen. Carbon dioxide is a greenhouse gas and linked to global warming.
Sulfur dioxide causes acid rain, and the oxides of nitrogen are poisonous to humans and also can contribute to acid rain.
The amount of gases allowed to be emitted varies across the world. For example, the EU, US and China all have different regulations.
The first standards came in with the CARB, the California Air Resources Board, in 1967. The first EU standards came in July 1992.
The following slide shows the Euro standards from 1992 to 2014. As is shown by the slide, there has been a general decrease in the amount of emissions. The unit used to measure emissions on the slide is grams per kilometre. Emissions can be measured in other units, such as grams per kilowatt hour. Some countries, such as India, have much slacker standards. One of the effects of this is smog caused by nitrous oxides and the hydrocarbons.
The only way to reduce carbon emissions is to burn less fuel initially. To do this, we have to increase engine efficiency and overall vehicle efficiency.
The main way of dealing with emissions is catalytic converters. There are two types, two-way and three-way. Three-way catalytic converters are fitted to most petrol engines. This has the added bonus of requiring a fuel injection system, which increases efficiency.
This is an example of a three-way catalytic converter. The main part of the catalytic converter is within this box here. It's two ceramic blocks like this. The blocks have hundreds and hundreds of tiny holes in that run all the way through. Even though the block's quite small, if it was opened out, it would cover the size of a football pitch. The block is coated in a mixture of palladium, rhodium and platinum.
These act as catalysts to reduce the carbon monoxide to carbon dioxide and hydrocarbons to water. The second block reduces NOx to nitrogen gas.
The catalytic converter works best when hot. It's heated by hot exhaust gases and the reactions taking place inside it. This means that if you can reduce the number of cold starts, you reduce emissions. Modern thinking puts the catalytic converter closer to the engine so it heats up faster. We'll now look at a new Zetec engine where this is true.
This is the new Ford Zetec engine, and as you can see, this is the catalytic converter is much closer here. This is necessary so it heats up faster. This is good because then it hits the light-off temperature faster, at which point it hits an efficiency of 80 to 90%. Before it hits the light-off temperature, efficiency is only 50%, so the faster it hits it, the better.
As well as legislation on emissions control, the government imposes the tax based on the CO2 the car emits. This slide shows the amount of tax paid compared to the CO2 emissions. The CO2 emissions of a car are becoming a selling point on cars that fit in the lower tax band.
This is a Citroen Vibe. It only produces 109 gram per kilogram of carbon dioxide. This means it's is the lowest paying bracket of the tax system, paying just £35 a year.
This is a Hummer H3 3.7. Unlike the Citroen, it produces 327 grams per kilometre of CO2, putting it well into the highest band, band G. It costs £400 a year for road tax.
It's the only way to reduce carbon dioxide is to reduce the amount of fuel burned. A lot of future thinking is based on this.
One option that has become popular in recent years is hybrid cars. These have an extra battery that is charged by the engine by methods such as regenerative braking. The battery can then be used instead of fuel at low speeds or to provide extra power when accelerating.
Dual fuels are another option, where two fuels are used in the running of the engine. Although this is actually less efficient, it reduces CO2 emissions by up to 20%.
Some cars are also purely electric, running just from a battery. Although there are no emissions from the cars, there are still emissions caused when generating the electricity in the first place.
Hydrogen cars are an upcoming concept. Currently, one is made by Honda. It runs purely of hydrogen, so the only emission is water. Again, there are emissions involved with producing the hydrogen.
So, overall we've seen that spark ignition engines produce emissions. The emissions, NOx, hydrocarbons and CO, are unwanted and can be reduced by the catalytic converter. Carbon dioxide emissions can only be reduced by burning less fuel. There are legislations and taxes imposed to aim to control the amount of emissions. Hopefully, emissions will continue to be reduced in the future.
Box. I've got no idea what this is.
Oh, you suck.
Okay. Carbon monoxide binds to the blood.
This is the new Ford Zetec engine. Stop laughing! Is that beautifully done? Oh, you're recording that?
Facebook.